Hello everybody, welcome to week 8. This is Wes, Trev, and Amy, and we're going to take you through affective and aesthetic outcomes of museum visits. To give you a quick overview of this presentation, I'll bring you through the introduction of this topic as well as our selected paper for this week. I'll highlight any connections to other papers that we've discussed either this week in previous courses, as well as the framework, keywords, lit review, and research questions. Wes will take you through the methods, study context, demographics, and participants, as well as the data analysis and the results. Trev will round out the presentation going through the findings and the discussion as well as the limitations of the study. He'll go through the calls for future research in this area of study and our question prompts for this week's discussion. We chose this paper by Price et al. Because it's super contemporary, published earlier this year in 2021, and is at the forefront of research in this area of affect and informal learning spaces. It also has many connections to this week's readings, previous week's readings, as well as previous courses. So, speaking of connections, there are a lot of them. Let's start with our previous course's knowledge. Epistemology, that is how we know what we know. We'll see Vygotsky come up again in his ideas of zone of proximal development and socio-constructivism. Gilbert and Beyer, specifically their 2017 paper on wonder. Pintrinch, his work on motivation is integrated with this paper, as well as all the work from Kuhn, Wozniacki, Zambilas, and Piaget, specifically around conceptual change theory, schemas, and accommodation. From this course, we'll see the 2000 paper from Falk and Durkheim, specifically regarding the CML, the contextual model of learning, and specifically the personal and sociocultural perspectives from that paper. Connections to this week's papers. Anderson et al.'s paper in 2016 discusses nostalgia and had connections to strong memories and how emotions can shape and reinforce memories. Dubov's paper from 2021 this year focused on YouTube as an informal learning space and considered emotional, behavioral, and cognitive arousal and engagement. Falk and Gillespie's paper from 2009 focused on the goosebumps fear exhibit, fear, emotion, as well as valence and arousal. Lesson et al.'s paper from 2016 discussed arts as a way to communicate science and affect people emotionally. Latham's paper from 2007 discussed aesthetic experience, profound emotional experience, and a transactional way to experience the world. All 5 of these papers discuss emotion in learning, specifically in an informal space, and that's a huge connection to this week's paper that we're presenting from Price et al. Just a quick heads up on some keywords and concepts to be aware of heading into this paper. Awe is one of the most complex emotions, and the common understanding is that it is generally considered a self-transcendent emotion that encourages individuals to focus attention outside of themselves and to extend beyond their momentary needs and desires. That's from page 138 in the paper. Vast is considered to be a physical enormity or an overwhelming sensory detail, a historical perspective, knowledge with an explanatory or conceptual power, or just sheer volume. Valence and arousal, these are as per Falk and Gillespie's 2009 paper. Valence is an increase or a decrease in pleasantness, so a high valence is something that would be positive or pleasant, and a decrease or lower valence is something that would be unpleasant. And arousal is considered on a gradient from alertness all the way down to sleepiness. So the CML and the GLO, these are learning frameworks that Price et al. Used to inform their study. We know the CML already from Falk and Durkheim in 2000, and remember this is specifically the personal and the sociocultural perspectives here. The GLO is the generic learning outcome, and there are 5 elements from this learning framework. These 5 elements provide evidence for learning. The first is activities related to the visit that take place before and after the visit. Second is change in knowledge and understanding. Third is attitudes and values. Fourth, inspiration and creativity. And the 5th, activity, behavior, and progressions. That's all from page 141 by Price et al. The last 2 keywords are emotion and affect, as quoted from page 141. Emotion is a psychological construct of many factors with much inter- and intra-personal diversity in construction. Affect is an associated neurophysiological state of feeling. Memory and awe are the focus of this study. Awe is an influential factor in informal learning, and thus museums want to capitalize on it. Price et al. Have done a previous study on the same concept with a slightly different focus, so you will see reference to that within the paper. They hypothesized that awe will be different between science and art museums, and that awe will lead to stronger memories of learning due to more emotional engagement. Awe as an emotion has an epistemologically constructivist foundation. 2 key features that stimulate awe are perceived vastness and need for accommodation. There are many triggers to awe, such as physical space, strong memories, art, social interactions, and surprise, and this can lead to multiple consequences, both positive and negative. On page 139, there's a quote that says, "Emotions are a key part of learning, and because awe is an emotion, it is also a key part of learning." Levitin in 2006 stated, "In the last 10 years, neuroscientists have shown just how intimately related our memory system is with our emotional system. Why awe works is sometimes creates surprise, which causes a disequilibrium, which causes learners to open up to new ideas. This leads to accommodation," again relating back to Vygotsky and the conceptual change theory, "and new knowledge can then be integrated into past schemas." Positive affect or arousal is linked to greater long-term learning in science, and affect leads to increased motivation, thank you Pintridge, and therefore supports long-term learning. So museum exhibits want to have the effect of engaging viewers emotionally, to helping them recall memories, as per Anderson's research, and helping them meet the expectations of the viewers. So this study assumes, or has its assumptions, that awe is created in museums and that emotional perceptions enhance long-term learning. Therefore, increased awe equals stronger memories. There are 3 parts to this research question. The researchers want to investigate the assumptions about the prevalence of awe, they want to investigate the types and facets of awe, and how awe is related to the context of the setting and what guests remember.
Methods and study context. The authors used a post and delayed post test with non-equivalent groups, with the different groups being at different science in our museum. This design enabled authors to make within groups and between groups comparisons and correlations. The post survey was performed at the end of the guest visit to measure awe of the overall experience, which was then compared to a delayed post survey a week later. The data was collected from 8 science centers and cultural institutions in 3 major U.S. cities. Fox 2018 paper suggested the need for more complex studies of learning across locations and time, so the delayed post test was included in this study. The sites were chosen according to the programming and scale attendance, with a focus on diversity among the sites. Post and delayed post surveys included 3 sections on demographics, a situational awe scale section, and a memories of learning and prior knowledge section. There are a number of moving parts in this study, so I've color-coded them to help keep track. The situational awe scale will be represented in blue throughout this section. The situational awe scale, or SAS, is a broad measure of awe that was broken down into 4 factors of awe. Awe is connecting, as in I feel free. Awe is isolating, I feel confined. Chills and physical metaphors of awe, my heart is racing. Diminished self, the world seems vast. This was measured by a 7-point Likert scale to assess this section. The memories of learning and prior knowledge section was assessed using a mix of Likert scale and constructed response, or CR, questions about what guests remember about the visit. This will be in red throughout the rest of this section. This was designed to create a broad measure of learning that includes elements of emotion and surprise. It was based on 4 main questions. What did you learn today? This included a follow-up Likert scale question of how much did you already know about this topic before today? Another question was, what is something you connected with today? What would you tell the director of exhibits? And what was something unexpected about your visit? The participants of this study included 899 guests who completed a post survey. 550 of those guests also completed the delayed post survey a week later. Overall, 59% of the participants were female, 37% male, 1% was non-binary, and 4% did not answer or prefer not to say. The average participant was 35 years old, had a bachelor's degree, visited similar institutions about 3.6 times per year. The delayed post-survey respondents were statistically more likely to be female and visit museums more often than those that did not respond. In terms of data analysis, all guest data was used in analysis of awe between institutions. However, only data from guests who also did the delayed post-survey a week later were used for long-term learning. Likert data was used to create scores for each factor of the situational awe score. The written constructed response items were then coded using a rubric that was based on the contextual model of learning by Dyer, King, and Pope, and the general learning outcomes model by Hooper, Greenhill. 7 categories or learning codes were created, and they were coded as present or not present in the text. These included personal context, visitor's socio-cultural context, before and after references, knowledge and understanding, attitudes and values, inspiration and creativity, activity, behavior, and progression. These are coded in green throughout the rest of this section. And the word written in brackets is how they will appear in tables. Of the 7 learning codes from the rubric, here are some examples for context. The personal context code included responses about the visitor in terms of why they visited, their interests, their attitudes and motivations for visiting, etc. There are examples on the right. Data analysis was performed using techniques from the general linear model, which is a framework for comparing how several variables affect different continuous variables. A simple correlation analysis between situational score factors and prior knowledge was performed. Analysis of variance, or ANOVAs, were used to make comparisons between multiple variables in the study. Here is a quick reminder on the color scheme for the different types of data in the study as we get into the results. The blue situational scale factors of connecting, isolating, physical, and diminished self were based on Likert scale questions. The red constructed response items were based on written questions about learning, connections, the exhibits, and surprising or unexpected things during the guest visit. The green learning codes are the breakdown of the constructed responses into learning categories such as personal, sociocultural, etc. The first set of results were that guests showed moderate levels of awe on post-surveys across institutions, with connecting and diminished self being the most common type of awe experience. In terms of institutional awe, there were consistent levels of awe between art and science institutions, regardless of whether the science center included animals. There was a small difference in the diminished self category between art and science. The constructed response items on the delayed post survey were used by the authors to look at awe and memories of learning. They found that the mean learning codes for the constructed response items were low, with an average of 5 learning codes per visitor across all categories. The major exception was in the knowledge and understanding code, with the constructed response question about learning, likely due to close coupling of item topic and rubric category. Table 5 shows the mean awe reported when particular learning codes were present in a guest response. This is a more specific breakdown of Figure 2 without accounting for any differences between science versus art institutions. Here are the results from the ANOVAs, where the situational awe factors and constructed response questions and learning codes were all analyzed together to determine predictors of awe. The authors mentioned traditional statistical significance, where probabilities or p-values of 0.05 is the threshold for statistical significance, but that they also look at trends and accepted slightly higher p-values as noted by the tilde, or squiggly line as Trevor calls it. The higher the estimate column value is, the stronger the relationship and the better particular learning code is at predicting awe. The significant relationships using the learning constructed response questions are highlighted here for reference. There's a lot of information here, so we're going to take out the relevant findings and put them into a separate table. Note that they use the word oppress rather than isolating on 2 of the tables. We believe this was a typo. Rather than looking at 16 categories across 4 tables, we've collated the significant results into one table. So reading across, you will take the situational awe score factor, how it relates to a constructed response item, and the specific learning code. Then we look at the measure of relationship and statistical significance. The higher the B value, the stronger the relationship is, and the lower the P value, the more statistical significance was found. Here are some examples of significant results. The relationship between the connecting awe factor, learning constructed response item, and knowledge learning code had a significant positive relationship shown by the positive beta value of 0.52 and probability value less than 0.001. The explanation for this relationship is that guests who reported higher levels of connecting awe were more likely to report a change in knowledge or understanding when asked about something they learned during the visit. The isolating awe factor had both positive and negative significant results with other variables. For example, isolating awe had a negative relationship, as shown by the negative beta value, with the learning constructed response item and the inspiration learning code. This means that the more isolated guests felt, the less likely they were to report feeling inspired by something they learned during the visit. Isolating awe had a positive relationship with the unexpected constructed response item and personal learning code. This means that the more isolated guests felt, the more likely they were to assign personal meaning to what they learned when they encountered something unexpected during the visit. Physical awe and diminished self-awe both had 4 significant relationships each. In the interest of space and time, we'll only look at some examples of what these relationships mean, but hopefully these relationships are starting to make sense. If not, the article describes the meaning of each relationship in detail as well. The physical awe factor had a positive relationship with the learning CR item and the knowledge learning code. This means guests reporting more physical awe were more likely to have acquired more knowledge or understanding about something they learned during the visit. The physical awe factor also had positive relationships with the unexpected CR item and both attitude and inspiration learning codes. This means guests reporting awe-related to physical responses were more likely to report feeling inspired or a change in attitudes and values when surprised by something during the visit. Significant relationships were also found with prior knowledge and museum-type data. For prior knowledge, more prior knowledge leads to higher levels of awe related to being connected to others and physical sensations of awe such as excitement. In terms of museum types, guests in science museums were more likely to experience diminished self-awe when compared to guests in art museums. This was the only significant predictor of awe that differed between art and science museums. Trevor will now take us through the discussion of these results.
Hey everyone, this is Trevor, and now we're going to look into Price et al.'s findings. Remember that research question way back at the beginning that Amy mentioned? Well, here's how they answered it. The researchers measured awe-related perceptions as guests left an institution and looked for relationships between these scores and memories of learning they held a week later. The authors found a consistent pattern among institutions in type and amount of awe that guests reported. Higher levels of awe were associated with more positive facets. Neutral levels of awe related to physical metaphors, such as feeling chills. And there were lower levels of negatively valenced awe, things such as feeling fear or threatened. They expected higher levels of physical awe at the zoo or to be associated with live animals due to added empathy, but they did not find it. Institutional type did have an impact on amount of awe guests related to feeling small or diminished self-awe. Art institutions showed less than science institutions. However, this was the only difference found between museum type. They did not notice much isolating awe, which is comprised of the more negative aspects of awe-related perceptions. They expected to see differences in isolating awe based on scope and size of the institutions of study, but did not find that. They found relationships between isolating awe and learning. These were always negative relationships. As learning increased, isolating awe decreased, but they could not comment on the causality between the two. They found a relationship between physical awe and memories about something unexpected happening, which could be evidence that surprise is more related to physical aspects of awe than other facets. Experiences of feeling small or diminished self had the most relationships with learning. Guests who felt small were more likely to discuss social interactions and implications of what they learned, and that what they learned was related to their values and understanding. This aspect is usually one of the first that people think about when they imagine or remember awe and increased prior knowledge was found to be positively related to connecting and physical awe. This is important as it challenges the notion that awe requires surprise. So awe can also be fostered by an appreciation about how much is being learned during an experience. Positive awe is tightly interwoven with the learning process and not restricted to particular stages. And relationships between awe and learning are sporadic and smaller in magnitude, but they exist and are consistently positive, which gives confidence that awe plays a role in learning. Next up are the limitations of the study. Price et al. Noted a few limitations with their study, including that the study did not test causal relationships between awe experiences and memory. The study was very broad in context, where museums and institutions of several kinds were included, so any measurable associations are also very broad and can increase the possibility of statistical errors. And the method by which the authors measure and interpreted prior knowledge of guests relied on self-reporting, which can be a measure of intrinsic curiosity more than an objective measurement of knowledge. Next up is future research. The authors pose several possibilities for future research. A similar study on empathy in place of awe to investigate how empathy differs amongst contexts. A follow-up study that includes performance centers, theaters, and cultural institutions without exhibits, along with a control condition to see if they show similar levels of awe. A more nuanced study on the impact of negatively valenced awe. More research on awe in real-world environments to expand on research from the institutional perspective. Studies on the social implications of awe. A a study on the causal relationship between awe experience and memory. And now that we know awe is consistent across institutions, a more focused study on direct learning measures is needed. That concludes our presentation. On this slide, we have our 3 discussion questions for you to choose from this week. The first one is reflect on a time you had an emotional response at a museum and describe how the experience has affected your memory of the museum. Second, describe an instance in your own practice where you engaged with your students' affective domain or sense of awe. What kind of emotional response did you or your students have based on this? And third, can learning in informal settings elicit the same type of affective, emotional, or aesthetic outcomes as can be achieved by learning in an informal setting? How does personal context play a role in the emotions experienced? And for those scoring at home, here's a list of our references.